Hello students, I am Praveen Kumar from ABS Engineering College, Ghaziabad. In this video, we will discuss about classification of DC motors. So, as far as DC motors is concerned, DC motors are mainly classified into five categories, which are: first is permanent magnet motor, second is separately excited DC motor, third is DC series motor, fourth one is DC shunt motor, and last one is the DC compound motor. Here we find out that the classification of DC motors is almost similar to that of generator, but here there is no category of self-excited motor. And there are simply three different types of motor. One is DC series motor, another one is shunt motor, and DC compound motor. And like generators, compound motors are further classified depending upon the connection of shunt field as long shunt compound motor and short shunt compound motor. So, first of all, we will discuss about permanent magnet motor. As the name suggests, in these motor, for developing working flux, pieces of permanent magnets are placed around the armature. So these motors are very compact in size, but due to low power output and constant magnetic field, as flux is developed by pieces of permanent magnet, so we cannot change motor flux. So because of constant magnetic field and low power output, these permanent magnet motors are rarely used in industrial application in spite of they are having an advantage of smaller size. Now the second type of motor is separately excited DC motor. So it is the line diagram of a separately excited DC motor. As the name suggests, so in this type of motor, two separate DC sources are used. One source is connected only for giving supply to the field winding. So here is the separate DC source which is utilized to give supply to the field circuit. So here is the field current which is flowing in the field winding, and purpose of this current is to develop flux of the machine. Here the armature circuit is independent of the field circuit, and another DC source which is the main supply of the motor which is connected to the armature brushes. So positive end, so this brush is positive brush and this brush is negative brush. And here is the current taken from the supply. This current is I, which is also known as line current, and as it is connected in series with the armature, so in this configuration, the value of line current and armature current both will be same, and they are independent of the field circuit as it is different. It is having no connection with the armature. Here, in this configuration, we can relate this supply voltage V and back EMF in the armature EB as this EB is equal to V minus IA RA, where RA is the resistance of the armature circuit minus brush drop if any brush drop is given in the diagram. Then next is for separately excited DC generator, we can define power input or power taken from the source or power input to the motor, that is V into I. Similarly, the power developed in the armature, mechanical power, which is equal to EB into IA. So these two relations are valid for almost all types of motor. One is the power taken from the source, that is the electrical power, and other one is the mechanical power developed in the motor armature, EB into I. For this configuration, the relation between back EMF and supply voltage is EB is equal to V minus IA RA minus brush drop. So this is a separately excited DC motor. As the name suggests, a separate DC source is utilized to energize the field winding, and field and armature has no direct connection to each other. Now moving to the next category, that is DC series motor. As the name suggests, in series motor, the field winding is connected in series with the armature and both are energized from a common source. So this is the supply voltage. This one is positive end, this one is negative end. So this is of V volt, and the back EMF in the armature is EB. Now, for this type of motor, relation between V and EB is equal to this. EB is given by V minus IA RA plus RSC minus brush drop, where IA is the armature current, RA is the resistance of armature circuit, and RSC is the resistance of this series field winding. One more thing, in series motor, as the supply line, series field winding, and armature circuit all are in series. That's why the value of all three current, means line current, is equal to the armature current, and it is also equal to the field current. So in series motor, all three currents are same. One more thing, the resistance of series field winding is kept very small so that the drop across the series field winding is small, or we can say we can minimize the losses of series field. So in order to minimize losses, resistance of series field is kept small, and that's why this series field is manufactured with the help of a wire having very thick diameter, and a very small number of turns are utilized in manufacturing series field. Now, moving to the next category of motor, that is DC shunt motor. As the name suggests, shunt motor. So in this type of motor, the entire field winding is connected in parallel with the armature, and armature and field winding both are energized by a DC source. So this is the supply voltage. This one is positive and negative. The voltage drop, the EMF, back EMF is available across the armature is EB, and we can relate V and EB as this back EMF EB is equal to V minus IA RA minus brush drop. This relation is almost similar to the separately excited DC motor. Here, in DC shunt motors, the largest current is the current taken from the supply, that is line current, and this line current is sum of armature current as well as field current ISH. So I am representing this current as IF. So here, one more thing, in shunt motors, this resistance of shunt field winding is kept as high as possible. The reason behind this is this value of field current IF is given by V divided by RSH. So if we kept this resistance high, means the field current will be smaller. And if this field current is smaller, means from the line current, larger amount of current will flow through the armature. And if the armature current will be large, then the mechanical power developed in the armature, which is given by EB into IA, will be high. So in order to increase the output of a shunt motor, we kept the field current as small as possible. And to reduce the field current, the shunt field winding is manufactured with a wire of very fine cross-sectional area and large number of turns. We have already discussed that the mechanical power for all types of motor is given by EB into IA. This is the mechanical power developed in the motor armature, and electrical input supplied to the motor. This input power is V into IL, where V is the supply voltage and IL is the line current. So this is DC shunt motor. Now moving to the next type of motor, that is DC compound motor. So in compound motors, the motor field winding is divided into two parts. One portion is connected in series with the armature forming series field, and another portion is connected across the armature forming shunt field. So compound motor, the field is, there are two field winding, and depending upon the connection of shunt field winding, the compound motors are further classified in two categories. One is long shunt compound motor, in which shunt field windings are long enough that they cover the armature as well as series field. And if the shunt field windings is connected only across the armature, then the motor becomes short shunt compound motors. In both the motors, first thing, the relation between line current, armature current, and field current is given by IL is sum of armature current and field current, or this ISH shunt current. So this relation is valid for both the types of compound motor. So first we will find out relation for this long shunt motor. Here V is the supply voltage. This is the positive terminal of supply. This is negative terminal. And from here we are having line current. This line current at this point is divided, and armature current is flowing in the armature as well as series field, and shunt field current is flowing in the shunt field winding, that is ISH. Now the relation between V and EB. EB is the back EMF, which is given by EB is V minus IA into RA plus RSC for this long shunt minus brush drop. So this is the relation between supplied voltage and back EMF for a long shunt compound motor. Here BD is the brush drop. Now for this short shunt motor, if we find out relation between V and EB, first of all we see that how current is flowing. Here from this point, the IL current taken from the supply line is flowing, and this entire line current is flowing through the series field winding, and at this point the current is divided into two parts. In armature circuit, armature current is flowing IA, and in shunt field winding the current ISH is flowing ISH. Now here for this short shunt motor, we can find out relation between supply voltage and back EMF as this EB is equal to V minus IL into RSC minus IA into RA minus brush drop. So this is different types of motors, and from this line diagram, we can easily relate the applied voltage, back EMF, and different types of current of the motor. So this is all about classification of DC motors, and these are the references which are utilized in making this video. I hope you have enjoyed watching this video. Thanks for watching. See you soon. Thank you.